Good afternoon, Ananda. In the today's class, we would like to discuss regarding the applications of this non-destructive evolution in the case of welding technology. Soon after, in 1 to 2 classes, we'll be finishing the 6th unit and completely we'll be finishing our syllabus point of view. And later, I will be halting your classes and I will be continuing this 3rd year classes. As far as our syllabus is considered, the castings we have discussed, oil and gas, petroleum industries, the NDT applications we have been verified clearly. Nuclear and non-nuclear, railway systems, chemical industries, automotive industries, we have a detailed discussion regarding it. In the today's class, we are processing with respect to the welded constructions or welded aspects. In the welding aspects, we will be discussing the non-destructive evolution and what different types of techniques that has been utilized for inspecting the welded conditions and in different agitations, how the defects have been identified and what range the defects has been identified based upon the parameters generated by this inspection process. What are the mechanical properties that are getting aged or getting deferred in the case of materials, we can conclude very much clearly. And in the tomorrow's class, we will be looking after this coal mining industries and in many industries, how this non-destructive evolution techniques plays a major role. By that, we will be concluding our syllabus. So initially, what is meant by this weld testing? Nominally, this methodologies has been utilized for ensuring whether the correct joint. So welding is nothing but the permanent joint that is being monitored in between the two different materials or else the similar kind of materials. So whether that particular joint, permanent joint, has been finished as per the specifications or as per the requirements or not, nothing but quality. So if the desired parameters has been mated with respect to the monitored conditions or worked out conditions, then we can assure that the quality has been maintaining. Nothing but it's the quality, it's the term that is referred to testing and even analysis. Also, that has been focused regarding the mechanical properties at the welded region that is in between the two different parts or it's a similar kind of parts. It should have a confide related to the holding of the entire other object with respect to one object. That is the basic phenomena will be testing that the joint is a fit or effortable in nature. So we'll be having an doubt that why the test need to be performed. So we already aware that indeed to verify the quality, indeed to verify the quantity, indeed to verify whether the desired parameters as per the requirements has been satisfied or not in the place of this manufacturing area. So detailedly, we can come across the entire these parameters and can have a better implementation processing techniques in the manufacturing area or within the industries or within the particular systems. Coming to the point of this qualitative, so and quantitative. So qualitative is nothing but we have already assured that the exact or correct dimensions as per the input dimensions achieved or not. Coming to the quantity, so quantity in the sense particular volume of the material has been filled out as per the statistics. Indeed, to achieve the mechanical properties of the materials, such as this hardness, tensile strength, ductility, malleability, toughness, fracture, etc. In order to access the suitability of this welding, particularly for different kinds of applications. In the case of this specific kind of the applications, normally you can see. So how the testing process will be getting considered in the case of this welding techniques or else at the welded areas. So coming to the inspection processes, there are different stages of inspection. That is, before the welding will be confiding with respect to the properties on observation. At the commencement of the welding process, non-DT, NDT process, non-destructive evaluation technique, we have a wide range of utilities that in-process inspection can be considered. So in-process inspection in the sense while the process is being considered taking place, automatically whether particular factors related towards the final output is being achieved or not based on the input parameters we are giving either manually or in the case of semi-automatic mode or else in the automatic mode. So whether the given inputs are being fed to the object or not by with the help of the tool, whether the machining process, if you have been considered the machining process, either it may be of the slotting or drilling, whatsoever it may be. So how much speed has been given? So how much feed rate has been given? How much depth of cut has been given? So whether it has been commenced or not will be obviously identified. So in the same way, in the case of this welding technology also, before welding process, during the welding process, nothing but while commencement of the welding process, and even after completing the welding process, you need to have the inspection for a better for analyzing whether it is a qualitative or better qualitative or better quantitative object or not. So we're having different techniques that is destructive and non-destructive. Coming to the point of this destructive, we have a detailed discussion with the differences between these two techniques. So destructive is nothing but the object will not be utilized furtherly for the inspection, such as our dynamic testing process, impact testing process, ISO testing process, hardness testing, Brinell, Rockwell, Vickers testing process, etc. will be coming under the case of this destructive type of testing process. Whereas this non-destructive testing process, which doesn't have the direct contact with respect to the work part and examine the process. Whereas in the destructive type, the materials furtherly will not be utilized and the materials under the test they will be getting deformed. Either it may be plastically will be getting deformed. Nothing but the dimensions will be getting changed. So plastic in the sense permanent deformations. So permanently the dimensions of the objects will be getting deformed. Coming to this non-destructive, there will not be any direct contact with respect to the materials by the tools. Obviously, we'll be having the inspection by different techniques and we'll get the results in a better way without any deformation in the materials. So before welding, see this by utilizing the solutions or offenses such as surface oxides or application of this grease or oils, there is nothing but we'll be calling as pre-cleaning or else the cleaning of the objects for getting the better results and sensitive results we can call as sensitive in the case of result orientation. Coming to the point of its dimensions and quality of the edge preparations. So, see in the pictorial representation upon application of the fluids and edges at different edges, and need to have a clear-cut examining process whether the welding agitation has been considered or not, or before commencing, how much distance of deviation or phase gap should be maintained. And the material will be filled out in between the two materials. And in order to join this one material to the other material, first the confinement should be considered and what parameters on different work material fusion state of welding or else the fission state of welding need to be progressed. So these are the analysis to be done. And instead of doing this any kind of welding process, so this pre-cleaning or cleaning is compulsion that to have a corrosion free of the materials. Next one, banking of the electrodes. So it makes possible of removing the moisture from the electrode coatings. Nominally, the tabular column will be, it has been clearly specified that E6010 or 6011 type of electrode has been utilized, which will be having the ambient with respect to the air. Nothing but normal atmospheric range of temperature. And a slight incrementing with respect to the normal atmospheric temperature. So E6012, 13, 14 and E7014, E7024. The type of electrodes will be utilizing and at the maintenance of temperature with respect to 100 to 150 degrees Fahrenheit. And the type of electrodes E7016, 7018 and 7028 can have the capability of generating the temperature at 225 to 300 degrees Fahrenheit of temperature. So what is the confining nature at the time of welding process that is being considered or that is being having? See, during the welding process, we need to have a clear cut input parameters such as selecting of the parameters such as how much voltage should be given in order to deposit the material in between the two different materials or similar kind of materials. Indeed, to consider the welding process or permanent joint between these two materials, or how much current or electrical power supply should be utilized, and how much volume of the material that is getting liquefied and deposited in between this materials in the case of a fusion state of welding. In the case of fusion state of welding, how much range of temperature should be utilized? For that, how much electrical power supply in the case of this current and voltage need to be supplied? And how much speed of this electrode should be maintained in between the materials? Nothing but the welding speed, shielding glasses for the safeguarding orientation, and temperature based on the type of electrodes, how much the types of materials, what type of electrodes should be utilized, and how much temperature need to be produced. Based on the temperature to be produced, what type of electrodes should be utilized as an input materials. This and all of the parameters should be considered in the case of input status for examining the or for commencement of the welding process. So after the welding process, is considered, the slag is a major problem, and that is depositing as a layer due to the welding process commencement over the parts or elements. So for the removal of the slag, The hammer plays a major role, and the chipping hammer normally will be called as a chipping hammer, not this hammer. And this pictorial representation clearly specifies the chipping hammer, that which removes the slag which is deposited in the layer format. Next, the peening. Peening is the stress removal process. And post-welding treatment. So after commencement of the welding, refinement of the grain structure and stress removal is the typical operational process which relates towards the stress removal. So stress that will be getting produced during the welding process due to the heavy temperature that is projected over the material. Nominally, thermal, we are having a property that if the temperature has been passed through the material, it will be passing to entire the material, and the similar temperature will be getting existed for the nearby materials also. That will be called conduction, convection, and radiation due to the different factors, that is radiation factors. And these thermal processes will be getting access in different conditions. That is either in the open loop condition process or else the closed loop closed processes, or enclosed surface area, or open to the environment. So open to the environment in the sense nominally normal atmospheric range of temperature. And within the closed environment means indeed to have the highest mode of temperature or welding to be progressed at a high range of temperature in the sense nominally enclosed conditions should be maintained for better achieving of the welding process. Post welding heat treatment. So after commencement of the welding, certain heat treatment process will be getting done for the stress relief. For the stress relief. And welding testing process. How these testings will be getting done. So in the destructive conditions, as we have been already discussed, that the materials will get deformed plastically. But in the case of this non-destructive techniques, without any physical damaging, nothing but that the inspecting material will not be having indirect contact with respect to the material, and hence will be getting the qualitative data obtained in both the conditions, but workpiece will be getting deformed in the case of destructive, and in the case of this non-destructive, they will not be having any of the deformations through the material. So material disturbance will not be getting considered in the case of this non-destructive. So destructive and non-destructive, that's the factors. So the main reason towards the defect occurrence is nothing but quality and hardness. And even the other some of the parameters are also nothing but lacking of the knowledge and skill of the welder. But training is required for this destructive type of testing process. So examining process. Nominally, in the case of this non-destructive evolution methods application, in the case of this identification of welded parts in the industrial sector. So majorly this technique, NDE techniques, different types of techniques such as radiographic techniques, ultrasonic techniques, etc. will be having a detailed discussion in the previous classes as per our syllabus considered. The major factors here is to detect the flaws and evolution of this flaws, Leakage detections, nothing but the gaskets, whether any deviations in the gaskets and joints and different joints that has been having with respect to and flanged couplings or else the permanent type of joint conditions. And even the location determinations, dimensional measurements, structural and microstructural characterizations, nothing but this terminology related towards the composition of the materials, composite materials. And estimation of the mechanical and physical properties, nothing but our strength, stress, stiffness, ductility, malleability, etc. Stress strain and dynamic response measurements and different types of stresses, shear stresses, tensile stresses, compressive stresses. And based on the incrementing of these stresses, automatically object will get deferred in its dimensions, which will be calling as changing in a dimensions leads to strain conditions. So strain is nothing but change in dimensions to original dimensions. So based on the stress imposement, automatically objects will get deformed in its shape as the dimensions will get changed. So strain, nothing but increasing of its or changing of its dimensions as being considered. So materials to sorting and chemical composition determinations. So why only this non-destructive is preferred majorly? Because it's too precious to be destroyed, and reusing of inspection also utilized by the test tubes can be progressed by this method of inspecting process. This test piece will be in service, can be used for minimal applications also, and even for quality control purpose also we can use. So what are the major types of this NDT? So detection of the surface flaws, visual magnetic particle inspection, fluorescent dye penetrant inspection, detection of this internal flaws, radiography testing process, ultrasonic testing process, and eddy current testing process. And these are the major types of non-destructive types of testing process that we are being utilized in the industrial sector for identifying the flaws. So surface level flaws, visual inspection, and if the flaws has been identified in the case of micro in nature or minimum in nature, which cannot be visible, this can be identified clearly with respect to how much dimensions, how much length or how much depth or how much thickness the flaws are being existing can be clearly identified in the case of this magnetic particle inspection and fluorescent dye penetrant inspection, detection of this internal flaws. Radiography is nothing but X-rays technology, Y-rays technology, gamma rays technology, UV rays technology, ultraviolet radiations technology. Nominally, most probably is preferred radiology, ultrasonic testing, eddy current testing process. In the case of visual inspection, so with our naked eye, we'll be getting visualized clearly the areas where the inspection has been occurred over the surface conditions. In the case of this dye penetrant testing process, application of this dyes, it's one of the primitive most technology utilized indeed to have a greater visualness at a glance and identifying clearly the defects in the objects. The materials which are commonly inspected in this technology are nothing but aluminum, copper, steel, titanium, etc. And even the ceramic materials, glass materials, and The rubber materials, plastic materials also plays a major role in the inspection process of technique. And why this liquid penetrant test will be delayed? So we are having six different steps as we have been discussed in detail in the working association of this liquid penetrant testing process. It improves to the flash detections with the color code of process where the penetrant will be applied over the object and that will be getting dipped over the crack. And wherever the surface cracks has been identified, clearly the penetrant will get passed over that particular crack and the color pigment clearly orient the crack indication up to which dimension that cracks are being existing. So the basic step it is pre-cleaning process, penetrant applying, dwelling for some time, next applying the developer and dwell conditions, and post cleaning also it is required. Post cleaning after the completion of the inspection process, post cleaning is also required for it. That is the liquid penetrant test technology. Coming to the magnetic particle inspection testing process. So application of this magnetic testing particle. So implication of this magnetization towards the objects. Here we are having three different types of materials, that is diamagnetic, paramagnetic and ferromagnetic materials, as we have been discussed detailedly in the unit number 3. Diamagnetic metals and magnetic properties inducement or acceptance objects only can be utilized to identify over this process. And with different techniques, we can examine the entire materials also. In the case of diamagnetic metals, weak and negatively susceptible magnetic fields will be getting generated, and they will get slightly repelled at the defected areas with respect to flux deviations. And that flux deviations will be clearly examined in the case of our oscilloscope. Coming to the point of these paramagnetic metals, these are very small and positive susceptibility towards this magnetic fields. Coming to the ferromagnetic, this is an iron and having the large and positive susceptibility because a good attractive towards the ferrous content of materials. Coming to the advantages of this magnetic particle inspection process, these are most dependable and sensitive methods that gives the clear-cut information related towards the surface measurement or surface defects measurement. This process can be commenced very much fast, rapid, and direct visual indication over the surfaces will be getting considered, the deviations or reflections. And this doesn't affect by the possible deposits such as oil, grease, etc. And even this process can be performed on the painted objects also. Surface preparation is not at all required for this. The results can be documented or tapped with respect to the impregnations clearly. Coming to the limitations, only good for ferromagnetic materials. Subsurface defects will not always be indicated. Relative indirect, relative direction between this magnetic field and the defected lines is much more important in the examining process for the oscilloscope. And object must be demagnetized before and after the examination process. These are some of the limitations. And commonly, in the case of welding technology, upon application, these are the some of the pictorial representations that are visible as per the welding commencement. has been taken place, welding process has been taken place. These are pictorial representations, identification of the cracks at the surface levels and the subsurface levels to some extent in the case of this magnetic particle testing process. In the case of this radiographic technology process, passing of these X-rays or else the gamma rays within a high frequency rays and examining those reflected rays back and identifying the cracks. So where will be applying this? Indeed, to identify the interior of an object, interior defects of an object. For example, in the casting defects, we are utilizing this radiographic technology and ultrasonic technology for inspecting internal bonding nature or atomic range of defects can be identified clear. Even in the welding conditions also, it's very much clear in case of identifying this. And these are the images that will be considered at the internal range of the objects. We'll be calling as a skeleton representation of the objects. So for this, these are the better advantage that internal specifications also clearly identified, but those will be having defects and some of the limitations. The gamma rays are very much generating from the copper of 60, which can penetrate up to 150 mm of the steel, but not more than that. The thickness can be measured. So if an heaviest objects or heavy thicker objects has been identified, need to be examined, this test does not at all preferred for it. And relatively operating also very much economical in range, and equipment is also very much used equipment, and skillful worker is necessary for operating over it. So clearly the crack positions can be identified and burn circles can be identified very much clearly. So these are the different kinds of non-destructive testing process that are used to identify the defects or the objects in the building conditions. And the next class will be moving on with respect to the industrial sector, and we will be concluding our syllabus. Thank you.